Part 4, finding the inverse of rational functions. Find the inverse of the function g of x equals 3 over x minus 5. State the domain and range of g and g inverse. So let's start with the domain of g of x. Here we know x cannot be 5 because then we divide by 5 minus 5 or 0. We can't divide by 0. In interval notation, that would be negative infinity to 5, union 5 to infinity. We don't know what the range of that function is, but we'll come back to find that. First, let's find the inverse of g of x. So I'm going to write it as y equals 3 over x minus 5, and then switch the x's and y's, which gives me x equals 3 over y minus 5. To solve for y, we need to first get the y out of the denominator, so I'll multiply both sides by y minus 5. And I get, if I distribute the x through, xy minus 5x equals 3. Now I need to isolate the y term, so I will add 5x to both sides, and I get xy equals 5x plus 3. And then my final step is to divide by x, and now I have y by itself. So y equals 5x plus 3 over x. My inverse, g inverse of x, is 5x plus 3 divided by x. Now my domain of this function, x cannot be 0 because again we can't divide by 0. In interval notation, that would be negative infinity to 0 and 0 to infinity. What about the range? Let's go back to the range of g of x. The range of g of x will be the same as the domain of f of g inverse of x. So our domain of g inverse, x cannot be 0. So our range of g of x is that y cannot be 0. And our range of the inverse function will be the same as the domain of the original function. So the range of our inverse function is y cannot be 5 because the domain of g of x was that x cannot be 5. Let's try another example. Find the inverse of the function h of x equals x plus 3 over 2x minus 1, and then state the domain and range of h. Well, the domain of h, we can find that. We know that 2x minus 1 cannot be 0, so 2x cannot be 1, and x cannot be 1/2. Now let's find the inverse. Our function, we have y equals x plus 3 over 2x minus 1. We'll start by switching the x's and y's, and I get x equals y plus 3 over 2y minus 1. So we have two different y's here, and we need to combine them into one. But let's first get the y out of the denominator by multiplying both sides by 2y minus 1. And distributing the x through on the left side, I get 2xy minus 1x equals, and on the right side, that cancels. We have y plus 3. My next step would be to get all the y's on one side of the equation. So I'm going to subtract y from both sides. And then I'm going to get everything without a y on the other side of the equation, which means I will add x to both sides. And now I have 2xy minus y equals 3 plus x. So notice all of the terms with a y are on the left side. All of the terms without a y are on the right side. Now to finish solving for y, I can factor y out on the left side. I have y times 2x minus 1 equals 3 plus x. Now I can divide by the 2x minus 1, and I have solved for y. So I've isolated the y. Y equals 3 plus x divided by 2x minus 1. So h inverse of x is 3 plus x over 2x minus 1. Notice the domain of this function is still x cannot be 1/2. Let's look at these two here. We have the function and its inverse are exactly the same. That does happen. It's not common, but sometimes that happens. If I look at the graph of this function, I can see why that's true. We have x plus 3 over 2x minus 1 is this graph right here. We have two different branches of the graph, but it is already symmetric about the line y equals x. So it is its own inverse.